Yeah, good evening, Harshit. Harshit, good evening.
Good evening, sir.
Just wait for 2-3 minutes till everyone joins and then continue.
Sir, when will we start the revision of science?
Which chapter? Yeah, which chapter are you talking of?
Sir, for half yearly.
Half yearly.
Yes, sir.
You want revision for your half yearly exam, right?
Yes, sir.
Okay, we can consider that from today only. We can consider the revision. And which chapter do you want to revise?
Sir, if we can you start gravitation in physics? I have gravitation.
Okay, you have your see gravitation only you are having, and other people I don't think that anyone will have gravitation.
Sir, if today we have to do chemistry, can we do with the second chapter?
Yeah, we can do chapter 2. We can do with chapter 2.
Okay, sir.
Okay, let's continue.
Sir, actually, what is the syllabus for this test, the science test on Thursday?
What happened?
What is the syllabus for the science test which was held on Thursday?
Syllabus sent means I didn't get.
Sir, what is the syllabus for the science test?
Okay, it will be sent today.
Sir,
Today
for
it will
this
be
Thursday, for half yearly mock test.
for half yearly. Okay, I'll just confirm with ma'am what all syllabus is she giving. Okay, I think she will be giving with the chapter cell tissues. In chemistry 2 chapters and in physics 2 chapters. So you have 2 chapters
Okay,
from
sir.
chemistry, 2 from physics and 2 from bio.
Sir, but the second chapter in biology is not finished.
Tissues.
Yes, sir.
Okay, so just I will check whether I have forwarded that chapter or not, and then we'll update you. So I think if people must be getting your tissues chapter also in your exams.
Yes, sir, I'm getting, but only plant tissues.
Only up to plant tissues.
Yes, sir. Half the chapter.
Okay, okay. So we have almost done about the plant tissues. Almost, I think we have completed plant tissues. Only the complex tissues were remaining. In the case of plant tissues, we were remaining with the complex tissues.
Yes.
Okay. Yes. Okay, just waiting for everyone. Then we can start with the revision.
Okay, sir.
Okay, so let's start now. So we want to do chapter 2. Okay, what about questions of chapter 1? Let's start with questions of chapter 1 and then we'll move to chapter 2 also. Start with chapter 1. And I have some good questions also from that chapter. So we'll continue with chapter 1 questions first. I'm forwarding them in your group. Okay, just see this question. Which of the following are matter? So we start with the first question. We'll start answering with Harshit. So Harshit, which of the following is a matter? You have chair, air, love, smell, hate. So which of them is a matter?
Chair, air, smell, almonds, uh, lemon, water, smell of perfume, sir. It could be also.
What about the smell of perfume?
Yes, sir.
Is it matter or not?
Yes, sir. Because the particles are going into the nose by which we are
The
getting the smell.
matter, perfume is matter, but the smell of perfume is not matter.
Okay, sir.
Okay. Perfume itself is matter, but the smell of the perfume you can't say it's matter. Got it? So smell of the perfume, it's not matter. Cold, it's not matter. Lemon water, yes, it is matter.
Yes, sir.
Almonds, it is matter. Uh, chair, air, they are matter. Whereas love, smell, hate, thought, cold, smell of perfume, they are not matter. Give reasons for the following observation. The smell of hot sizzling food reaches you several meters away, but to get the smell from cold food, you have to go close. Why it is so?
Sir, because in the hot sizzling food, the intermolecular spaces are high, so it can spread easily, whereas in the cold food, the intermolecular force spaces are less.
What? Repeat again.
So the intermolecular spores spaces are high in the hot sizzling food.
Okay, Jitendra.
Yes, sir.
Okay, can you answer this? Question number 2. Can you answer question number 2?
Sir, because the matter is continuously moving.
Yes, it is because a hot sizzling food, it has a higher energy. The particles of the hot sizzling food, they have a higher energy. So they have higher energy and hence they are continuously moving. So you get a smell from a distance. Okay. For the question number 3, a diver is able to cut through water in a swimming pool. Which uh, which property of matter does this observation show? Yes. Which property of this is shown? Sharwan? Sharwan,
Yes, sir.
can you answer? A diver is able to cut through water in a swimming pool. Which property of matter does this observation show? See, you have different things here. The different properties of matter are like matter is made up of tiny particles. The particles are continuously moving. The particles have space in between them. Okay. So you have all these properties, and out of these
Sir,
properties,
water has more space.
the particles of matter, they are continuously moving. Okay, and or you can say matter is made up of tiny particles. Since matter is made up of tiny particles, so that is why a diver is able to cut through them. What are the characteristics of the particles of matter? So tell the characteristics of the particles of matter.
Sir, particles are tiny, particles are spaces between them, particles are continuously moving.
Yes, particles of matter, they are continuously
Particles
moving.
attract each other.
Yes, the particles attract each other, and any other. Okay, let's see the next one. We have the states of matter. So there are three states of matter. We can say solid, liquid, and gas. And as we know by the properties that in solids the particles are tightly packed. Solids have a definite shape and size, whereas in liquids the particles are not tightly packed and they do not have a definite shape and size, but they have a fixed volume. So liquids have a fixed volume, but they do not have a fixed shape and size. Whereas the gases, they neither have a fixed shape and size, and they also not have a fixed volume. But so, and see how we can convert from one state to another. It can be done on two bases, depending on the space, or you can either convert them depending on the basis of energy. So if you consider the amount of energy, so see here the three substances they are shown: solids, liquids, and gases. So in solids, we observe that the particles are tightly packed. In liquids, the particles are loosely packed, whereas in gases they are free to move. Okay. Also, if you observe of the energy, so in solids or liquids or gases, in which of them is there a greater energy? Which of them has a greater energy?
Solid.
Okay. See, the particles of gases, they are continuously moving. Okay. Since the particles of gas, they are continuously moving, so therefore they possess more velocity and hence they possess greater kinetic energy. मशीन में दबा है अभी रखने के लिए चाहिए अच्छा ठीक है Got it? So highest energy or highest amount of kinetic energy is available with the gases. Then liquids have a lesser kinetic energy, and solids, the particles of solid, they have the least kinetic energy. So in terms of kinetic energy, if we look, so kinetic energy is a representation of temperature. More the temperature, greater will be the kinetic energy of the substance. So if you want to change the state of substance from one state to the other, you can increase or decrease the amount of kinetic energy by either supplying heat or absorbing the heat from it. For example, suppose if you want to change the state of a ice to liquid state, so you apply some amount of heat energy, and that heat energy which we supply, it is used to convert, it is used to provide molecular motion, or it is used to increase the energy of the molecules, and therefore the molecules, they start moving with greater velocities, and hence they come to a stage of liquid state where they are continuously moving. Understood how we are able to achieve the liquid state from the solid state? That is by increasing the energy. If we observe, if we increase the amount of energy supplied to the solid, so the particles, they start moving continuously, and the movement of the particles, it increases their kinetic energies. Got it? If we supply still more energy, so the amount of motion of these particles, it will still increase, and hence the particles will be free to move, and the object will get converted to the gaseous state. The same thing we can do if we want to convert the state back to the solid state. Since gases have the maximum amount of kinetic energy, we can absorb the kinetic energy by cooling it. So if we cool it, we are absorbing the kinetic energy from these molecules. So slowly and slowly, if we decrease their energy, so slowly they get converted to the liquid state, and the liquid slowly get converted to the solid state. Understood this concept?
Yes, sir.
Okay. The other concept is by the space between them. So see, uh, suppose if you have gases, and we can see that there is a lot of space between the particles of the gas. If we can try to decrease the space between the particles by applying some pressure, so if we apply the pressure, decrease the volume, so the space between the particles will decrease, and when the space between the particles will decrease, it will come to a stage which will be the liquid state. Got it? So this is the method that we use for CNG, which we call as the compressed natural gas. So it is called as a compressed natural gas because the natural gas that is there, it has been compressed. A pressure has been applied on the molecules so that they get converted to the liquid state. Got it? So that is why you have compressed natural gas. Then if you further apply pressure, so further application of the pressure will still decrease the molecular motion, and hence convert it to the solid state. So the two factors which determine the state of a substance, they are pressure and temperature. So these two factors, pressure and temperature, they determine the state of a substance, whether it will be a solid, liquid, or a gas. Understood the role of the two things, pressure and temperature? It's neither allow, you can't do it only with temperature, and you can't do it only with pressure. Both the things, they play their roles. Okay, see this one. The mass per unit volume of a substance is called density, or we have density given as mass over volume. Arrange the following in order of increasing density. So you have to arrange these in order of increasing density. For air, exhaust from the chimneys, honey, water, chalk, cotton, and iron. So you have to arrange them in the order of increasing density. So which one should be the least denser? Yes, which one should be least dense? Go on.
Sorry,
Sharman,
can you repeat?
first question. We are doing the first question. Jitendra, very good. Jitendra, answer the question.
Sir, air.
Air is the lightest one. It has the least density. Then
Exhaust from chimneys.
Yes. Then exhaust from the chimneys. Then
Water.
okay. Then you have water or cotton. Which one will we have?
Cotton,
Water,
sir.
cotton, and then
Water.
water. After that,
Honey.
honey, and then
Chalk.
chalk. Okay.
Iron.
Iron. Okay. Then tabulate the differences in the characteristics of states of matter. So this I think you can write down. You just have to list the differences between them. Okay. Now see this question number 3. Give regions a gas fills completely the vessel in which it is kept. Yes. How does a gas fills the space completely? Yes.
Sir, can I answer?
Yes, you can.
Sir, the particles of matter are continuously moving.
Yes, the particles of matter are continuously moving. So that is why a gas exerts pressure on the walls of the container. Since the particles are continuously moving, so during their continuous motion, they go and collide with the walls of the container and hence exert pressure on it. A wooden table should be called a solid. Why should we call a wooden table to be a solid?
So because it has a proper shape and occupies a fixed volume.
What we shall do?
So it's because the wooden table which is there, it has a proper shape and occupies a fixed volume.
Okay. It has a definite shape and size. That's the reason. We can easily move our hand in air, but to do the same through a solid block of wood, we need karate expert. Why? Yes, Jitendra. Very good. Jitendra is answering. Jitendra,
Sir, in water, the intermolecular spaces are more, but in solid, the intermolecular space is less.
the force of attraction between the molecules. Can we call this in terms of force of attraction between the molecules?
Yes, sir.
The force of attraction between the molecules of a liquid, they are weaker, whereas the force of attraction between the molecules of a solid, they are stronger. So that is why to move our hands between the molecules, we need a karate expert for solid, but for liquid, we can keep it as it is. Then last this question number 4. Liquids generally have lower density as compared to solids, but you must have observed ice floats on water. Why does ice float on water? Sampath?
Sir, this is due to the special property of water, that is abnormal behavior of water. After 4 degrees Celsius, when we cool it, the water particles start to expand. While expanding, they increase the spaces between them. As a result, they'll have low density than of water, so they will float on water.
Okay, see, you can say that the due to the molecular arrangement or due to the arrangement of the particles, ice has a lower density as compared with water. Okay, a small two-step answer you can add here. Then, can matter change its state? So obviously, matter can change its state. We have a solid can change to a liquid state. A liquid can change to a gaseous state. A gas can change back to liquid state, which we call as the condensation. So these are the three changes which we expect here. We expect a solid, liquid, and a gas. So change from solid to liquid is called as melting. A change from liquid to solid is called solidification, or it is also called as freezing. Then liquid to gas, it's called sublimation. Solid to gas is called sublimation. Gas to solid is also called solidification. Or liquid to gas is called evaporation. Whereas gas, change from gas to liquid state is called condensation. So yes, matter can change its state. Solid to liquid, it's called, if you want to change from solid to liquid, you have to supply heat, and from liquid to gaseous state, you need to supply heat. But if you want to change from gas to liquid, you have to cool. Again, if you have to change from liquid to solid, again you have to cool it. Then see this one. I think the separation of substances is not there, but say this process shows us the sublimation process. You have heating of ammonium chloride. So heating of ammonium chloride, it's the sublimation process. We are separating, or we are purifying camphor or ammonium chloride by the sublimation process. Since camphor, it can directly change from solid state to the gaseous state, we can save it, we can separate the contents by evaporating it or by heating it. So if you heat, we observe that camphor, it changes directly from solid state to gaseous state. And as it goes up, the funnel is there which is cool. So funnel solidifies the vapors of camphor, whereas the impure substances, they do not sublime, they remain as it is in the china dish. So in this way, we can separate the contents. Okay, effect of change of pressure. So see. Effect of pressure or effect of change of pressure, we had seen that I become voltage. So now the effect of change of pressure. So if you increase the pressure, as we just did about the conversion from one state to the other, when we are increasing the pressure, we are trying to decrease the space between the molecules. And if you decrease the space between the molecules, so they will get converted from gaseous state to the liquid state, and from liquid state back to the solid state. One more thing here, we need to study about the boiling point. Can anyone state what is boiling point of a substance? Or how do we define the boiling point of a substance?
The boiling point means at the temperature in which liquid changes to gas.
So, but then what is the difference between boiling and evaporation?
Sir, boiling means the liquid changes into gas only at the boiling point, whereas in evaporation, the liquid changes into gas at any temperature above the freezing point. And also, it causes a cooling effect.
Okay, see, evaporation occurs at all the temperatures, and boiling point is the temperature beyond which you cannot increase the temperature. The boiling point means the temperature. Hmm? It means the boiling point means the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure. So here atmospheric pressure plays an important role in determining the boiling point. Understand this concept and you'll find a question based on this concept. So here now we have boiling point in terms of atmospheric pressure. So first of all, let's try to understand what is atmospheric pressure. Pranav, 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 are you there, Pranav? Pranav, are you there? Shravan?
Yes, sir.
Okay. So what is atmospheric pressure?
Sir, I don't know.
No, no. See, okay, Pranav, what is atmospheric pressure? See, atmospheric pressure, it is the pressure exerted by the air around us. Okay. So the pressure exerted by the air around us is called as the atmospheric pressure. So the atmospheric pressure is different at different points. For example, atmospheric pressure at sea level. Okay. Atmospheric pressure at on a mountain peak. Do you think the two atmospheric pressures will be same?
No, sir.
Atmospheric pressure on mountain. So which one will be greater?
Sir, atmospheric pressure on mountain.
Yeah, atmospheric pressure on the mountain will be lesser. It won't be greater. See, it's like this. Try to understand how it happens, how the atmospheric pressure is determined. Hmm. So here, the blue circle that you observe, that is our Earth, and around the Earth you have the atmosphere. Okay, so you can observe that our atmosphere is everywhere, and this space that we see, it is filled with air. So if somewhere you have a mountain, suppose here somewhere you have a mountain, and here it's the sea level. Again, you have the mountain somewhere, then sea level. So on the mountain, here you have a small height of air, whereas for the sea level, you have a greater height. So out of the two cases, if we observe, here we have, okay, here it's the greater height and here it's the lower height of the atmosphere. So at the mountain peak, the atmospheric pressure will be low. As in class 8, we have studied that pressure exerted by fluids, it depends on the height, and air is a fluid. So pressure exerted by air will depend on the height. Where you have a greater height, at that place you'll find a greater pressure. Whereas at the places where you have greater heights, okay, sorry, at the greater heights here, you will have low pressures. Here you have a low pressure and here you have a high pressure. Because the depth is more in terms of fluid, we can say here depth is more. So here it will be a high pressure. Got it? So on the sea, here the atmospheric pressure will be higher as compared with the atmospheric pressure on a mountain. So see what effect will it have on the boiling point. Now, when we are boiling any substance, boiling point, when do we say that the boiling point is attained? Suppose I am heating any liquid. Here I am heating a fluid, a liquid I am heating over here, and I'm continuously increasing its temperature. So its rate of evaporation is increasing. The molecules are converting to the gaseous state faster and faster. Okay, so they are converting to the gaseous state because the pressure of those molecules is less than the pressure of air. When the pressure exerted by these molecules which evaporate, they also start creating a pressure. And when the pressure of these molecules becomes equal to the atmospheric pressure, then we say that it is the boiling state. Okay, understood what is boiling? So boiling is the situation when atmospheric pressure is equal to the vapor pressure. What is the boiling point? It is the temperature it is the temperature at which the pressure exerted by a liquid exerted by a vapor is, or let's say by a liquid, is equal to atmospheric pressure. Okay, so that temperature at which the vapor pressure of the substance will be equal to the atmospheric pressure, we call that pressure to be the atmospheric pressure. So for example, here we are heating it up, so its vapors are continuously increasing, they are increasing the pressure. Okay, so the pressure, when the pressure of these gases becomes equal to the atmospheric pressure, we say that the boiling point has reached, and therefore there will not be any further increase in its temperature. That state we call as the boiling state. Understood this one? Understood everyone? Because now I am going to ask you a question based on it. Yes? Okay, so now try to answer this question. I'm cooking food in open pan. Okay, so I have an open pan. I don't have a pressure cooker. So I'm cooking food in an open pan. So will there be any difference in the time taken to cook the food if I'm cooking on a hill or I'm cooking at the sea level? Will there be any difference?
Yes, sir.
Yes. So what difference will be there?
So when we are cooking up at the well, the boiling point will be reached more fast due to the less atmospheric pressure.
Yes, on the mountain peak, its boiling point will reach shortly. Okay, so that means here on the mountain, the boiling point will not be 100 degrees centigrade. On the on the hilly area, here the boiling point may be suppose 80 degrees centigrade. it may be 80 centigrade, whereas on the sea level, the boiling point may be about 100 centimeter. Oh, sorry, 100 centigrades. So here my water is attaining a temperature of 100 degrees centigrade, whereas on the hill it is attaining only a temperature of 80 degrees centigrade. So where will it be easier to cook? So that will be here, where it's attaining a greater temperature. So it will take a shorter time for the food to be cooked. Okay. As an example, when we are using the pressure cooker, when we are using the pressure cooker, okay. So why do you think that use of pressure cooker cooks the food faster? Can anyone tell why, when we are using the pressure cooker, the food is cooked faster?
So the boiling point of water is reached faster.
What happened? Repeat again.
So the boiling point of water is reached faster.
No, see, in the pressure cooker, water attains a temperature of about 300 to 400 degrees centigrade. In the pressure cooker, this is the temperature attained by water. Got it? Whereas in an open pan, in the pressure cooker, this is the temperature. Whereas in an open pan container like here, the maximum temperature that I can reach is 100 degrees centigrade. So definitely, food will be cooked faster in a pressure cooker. Yeah, got it? So understood this role of atmospheric pressure?
Yes, sir.
Okay, let's see these questions now. Yeah, about the temperature scales. Let us try to understand this one also, about the temperature scale. So there are different temperature scales which are generally followed. However, there are 4 scales, but we will study here about the different temperature scales. The 3 different temperature scales, they are our Fahrenheit, degree centigrade, and Kelvin. So the temperature in Kelvin, it is also called as absolute temperature. This is not a comparative temperature. This is an absolute temperature. The temperature in degrees and the temperature in Fahrenheit, they are the relative temperatures. In the degree centigrades, the freezing point of water is taken as 0 degree centigrade. So here, freezing point of water, it's taken to be 0 degree centigrade, and boiling point of water is taken to be as 100 degrees centigrade. For Fahrenheit, the freezing point is taken as 32 degrees centigrade. It is 32 degree Fahrenheit, and the boiling point is 212 degree Fahrenheit. For the Kelvin, the freezing point is 273 Kelvin. The freezing point is 273 Kelvin. and the boiling point is 373 Kelvin. Here, if I say about the 0 Kelvin, so 0 Kelvin is the absolute temperature. We call 0 Kelvin to be the absolute temperature or the least or minimum possible temperature in the universe. The minimum possible temperature in the universe is 0 Kelvin. Understood this? All of them?
Yes, sir.
In Fahrenheit, the temperature range will be the same. 212 minus 32 will be the same as 100 minus 0. Okay. So a conversion scale is there between degree Celsius and Fahrenheit. If you want to convert to Fahrenheit, so degree Fahrenheit temperature will be equal to 9 over 5 times of degree Celsius plus 32. Got it? So can you convert what will 37 degrees Celsius be in Fahrenheit? Anyone? Can anyone perform and obtain? I want to convert 37 degrees centigrade to Fahrenheit. So in degree Fahrenheit, this should be equal to 9 over 5 multiply 30 the temperature in degree centigrade plus 32. Okay. So you get this one as
98.6 degrees degree Fahrenheit.
98.6.
Yes, sir, 98.6.
Okay. So if you solve this, you are getting 98.6 degree Fahrenheit. So see, this is our also called as our normal body temperature. Our normal body temperature is 37 degrees centigrade. Or in terms of Fahrenheit, this is in terms of Fahrenheit, this is 98.6 degree Fahrenheit. In terms of Kelvin, see, a Kelvin has a very simple conversion. If you want to convert any degree Celsius temperature to Kelvin, so Kelvin temperature will be given as degree Celsius temperature plus 273. You just have to add 273. You will get the temperature in Kelvin. Anyone having any doubt here? Okay, let's try these questions now. Convert the following temperature to Celsius scale. So how can we convert?
So 300 minus 273 Kelvin.
Yeah, 300 minus 273. You can use the formula of Kelvin. You can write it. The Kelvin temperature was equal to degree Celsius plus 273. So if you want degree Celsius, it will be degree Celsius will be equal to Kelvin minus 270. So Kelvin temperature is given as 300 minus 273. It makes it 27 degrees centigrade. So in the next one is Convert the second one. It's 573 Kelvin. What will be the answer for this? 573 Kelvin in degree centigrade. Obtain it quickly. 573 Kelvin to degree centigrade.
300.
Yes, it's 300. In degree Celsius, this is 300 degrees Celsius. Okay, for the second one, what is the physical state of water at 250 degrees centigrade? At 250 degrees centigrade, what will be the state of water?
Sir, water vapor.
Sir,
Yes, it will be in gaseous state, so it will be steam. And what will be the state of water at 100 degrees centigrade?
Sir, both liquid state and gaseous
Yeah, it
state.
will be both. It will be both liquid and gas. Think for question number 3. For any substance, why does the temperature remain constant during the change of state? Yeah, why does the temperature remain constant during the change of state? Anyone got the answer?
Sir, can I answer?
Yes.
Sir, it is because the extra heat is used in the form of latent heat, which is used to separate the
So
molecules.
why it is latent heat? Why there is no rise of temperature?
Sir, to overcome the forces of attraction.
Yes. Okay, so whatever energy we are supplying as a heat energy, that energy is used to overcome the forces of attraction between the particles. And hence, it is not used to increase the speed. It is only used to overcome the forces of attraction. And hence, there is no rise of temperature. Suggest a method to liquefy atmospheric gases. Is there a method to liquefy atmospheric gases?
Yes, sir.
Okay. So which method?
Sir, by applying pressure.
Yes, by applying pressure. By applying pressure, we can liquefy the atmospheric gas. Okay, any other doubts in these questions? Okay, also one of the assignment I have sent in your group from this chapter. Okay, you can do solve those questions, that assignment from this chapter. Okay, just we have here some more questions, and this we'll see in our later classes why how evaporation causes cooling effect. Okay, so bye all of you. See you again in next class. Thank you all of you for joining and being active.